Hello students, in this video we'll discuss about deterministic context-free languages. In the last video we have discussed closure properties of CFL. Okay, what is meant by deterministic context-free language? Let me go recall the DFS and NFS. See, DFA means on any state if you read any input symbol it must go to same exactly one state, right? But NFA may go to 0 or 1 or more number of states. See, every DFA is NFA, right? Every DFA is NFA, and every NFA can be converted to DFA. Right? For example, assume that we are having 1 crore languages which are directly represented by DFA. Those are all itself NFAs. Assume that we have 2 crores languages where we are easy to construct. Those 2 crores can be converted to DFA. So we can't tell any language which is accepted by the NFA that is not by DFA or accepted by DFA that is not by NFS, because the power of both the languages are equal, right? The languages accepted by the DFA, number of languages must be equivalent to the number of languages accepted by the NFA. But here, see, when it comes to deterministic, the number of languages accepted by the non-deterministic PDS are more than the deterministic context language. Means certain CFLs cannot be recognized by the DPDA, right? So that can be recognized by DPDS are called as deterministic context languages. Especially they are useful in parsing programming languages. Non-deterministic means ambiguity will be there, that will give you some problems. Before going to the definitions of it, what are such? See guys, for example, if you are given some languages like a power n, b power m, c power p, such that n equivalent to p. Here the number of a's must be equivalent to number of c's. So for every a you push it. I know exactly I can push a. So for b no operation. For c pop the a. Here I know which are involved in the comparison. Then what we have to do for push, what we have to do for B, what we have to do for C. Exactly I know when we have to perform which operation. That is called deterministic in nature. Deterministic means exact. But when I take the same another language like this, L equivalent to A power N, B power M, C power P, such that N equivalent to M or M equivalent to P. In some strings AB are equal, in some strings BC are equal, right? In some strings. For example, if I take the language like this, say I can take epsilon, all are equal. I can take only A, in this BC are equal. I can take only C, in this AB are equal. I can take like this, AB or BC or AABB 1C or ABBCC or AABBCC or AAABBB 1C or 1A triple B triple C. Now if I ask a question here like B, I can take ABC or AABBCC or AABCC or triple A 1BCC. I can tell whether A is involved in the comparison, yes. B, no. C, yes. I can tell it exactly what should I do. But here, whether A is involved in the comparison, may or may not be. In some strings A is involved, in some strings A is not involved. So what should I do when A occur? We have two. It is involved, so perform the push. Sometimes it is not involved, so perform no operation. For the same variable, we are having two different natures. That's why this is not accepted by the DPDA. So this is only accepted by NPDA. Such languages are called as only contextual languages, but not, this language is not a deterministic context-free language. This is only a context-free language, but not deterministic. That's the reason I told you the power of both the languages are not same, right? So in DPDS, each step at most one way to proceed according to its transition function. We should have only one way. So these are more complicated than DFS because DPDS may read input symbol without popping from the stack and vice versa. We can do such. Sometimes we can pop out and input symbols. See, input state is Q. String is epsilon when no push, no pop operation. But we can do some popping out operations in this next stack moves. A epsilon popping out, no push, no pop. And we are not removing anything, but popping something. So we can do the different things with the DPDS. Okay. So epsilon moves are given, but other moves are not allowed instead, right? So in DPDA transitions, we have already discussed that in the DPDA concept in the last unit, in the second unit, what by writing such. Okay. So indicates sometimes which may indicates no action here. See, here we are having QAX and going to the R and performing some different action. It is not push or pop or no push, no pop. So this is sometimes maybe allowed. Q reads pops X and goes to state R and pushes Y. Means the X is popped and Y is pushed here. So it is doing two different things at a time, right? And sometimes no action should be performed. Okay, reads A and pops the X. Okay, so one of the states must be non-empty to define that it is a deterministic PDA. Of course, let me go with this. So these are some situations where we should have the DPDA. DPDA is exactly one move in every situation when its stack is non-empty. That's what we are telling, keep on telling. Okay, let me write all these things with a single notation, guys, what we have discussed earlier. See, indicates no action, single move sometimes. In another way, we are performing more than one action at a time, right? So popping of X, and sometimes we are performing no reading, but we are performing some actions. So these are that. And one of the three actions, right, must be non-empty. We should not have anything to enforce the deterministic behavior. Okay. Then what are the other possibility of this same thing? Let me go with the last point, whatever I have discussed here. Exactly one situation means on any state, if you read any input symbol and a particular stack symbol, then you should go to the one state by performing one operation. Going to Y by performing push. For example, if I'm having like this X, A, Z, same input symbol saying, if you are going to the same state by performing different operation, not DPDA. Should not have like that for the same situation. Or if you are having the same situation but going to a different state by performing the same operation is also not DPDA. Same state, same input symbol, same top of the stack. You must go to the same some one state by performing the one operation. Going to different states is not DPDA. Going to different performing two different operations also not DPDA. Assume that you are given a automata and you are asked to check whether it is DPDA or not. Okay, make sure that we should not have empty also, right? Then see here Q2 0 where we are going Q2 by performing some operation push and pop and this. Okay. So now we have constructed the 0 power n 1 power n like this. Okay, Q1 you can take it. So 0, right? And if the top of the stack is Z, then you can perform the push operation. In that way you can do it. And after constructing the table, check each and every cell here. So nowhere we are having the more than two actions for the same situation. If you have such, then we can say that the grammar is, the automata is DPDA. So if a language is accepted by DPDA, those are called as deterministic context-free languages. If they are not accepted by the DPDA, but NPDA, they are called as CFL. So regular means either it should be DFA or NFA. DCFL means only DPDA. CFL means simple PDA, or sometimes we can even call it as NPDA. So the power of DCFL, the subset, these DCFL languages are subset of CFL. Every DCFL is CFL, but not all CFL are DCFL. For example, we have taken already L1 equivalent to A power N, B power M, C power P, such that N equivalent to M or M equivalent to P. This is not DCFL, but CFL. And we have L2 like WWR, such that W belongs to A comma B whole star. This is also These two are not DCFL but CFL. We have such languages. Okay. So let me go with the closure properties of DCFL. When it comes to the CFL closure properties, they are not closed under complement, intersection, and difference CID properties. But when it comes to the DCFL, the complement, even we can close under complement. But they are not closed under union, reverse C. Union is not closed. Intersection, clean closure, reversal. So these are not closed. So in the next video, we'll discuss about the decision properties of CFL. So same decision properties we have even discussed for the regular languages like membership, emptiness, finiteness, infiniteness. See, closure properties are different. Decision properties are different. Closure properties means performing some operations on languages. Decision properties means we are checking some properties on languages. Operations are different, properties are different. Okay, so that decision properties we'll discuss in the next video.